Why do we blink thousands of times every day? Every few seconds, you briefly stop seeing the world. Light is blocked, your eyelids close. For a tiny fraction of a second, your vision disappears. And yet, you've probably never noticed it happen. By the end of today, you'll have done this thousands of times. In fact, if you added up all those tiny moments with your eyes closed, they would total somewhere between 30 and 45 minutes. It's as if your brain quietly erased nearly an hour of your vision every single day. So why doesn't the world seem to flicker? Why don't you experience thousands of tiny moments of darkness? And if blinking interrupts vision, why would evolution keep such a strange habit? The answer turns out to be far more remarkable than simply keeping your eyes wet. Most people think blinking is just a way to moisten the eyes. That's certainly part of the story. Every time you blink, your eyelids sweep across the surface of your eye like tiny windshield wipers. They spread a fresh layer of tears over the clear front window of the eye, the cornea. This tear film isn't just water. It's made of 3 carefully balanced layers: an oily layer that slows evaporation, a watery layer that provides moisture and nutrients, and a thin mucus layer that helps everything stick smoothly to the eye. Together, they create an almost perfectly clear optical surface. Without this smooth coating, light would scatter before reaching the inside of your eye. Your vision would gradually become blurry, uncomfortable, and dry. Blinking also washes away tiny dust particles, pollen, and other debris before they can cause damage. It even helps spread substances that fight bacteria and reduce the risk of infection. So yes, blinking keeps your eyes healthy. But that explanation raises another mystery. If blinking is mainly about lubrication, why do we blink so often? Under relaxed conditions, most people blink around 14 to 20 times every minute. That's roughly 1 blink every few seconds. Yet something curious happens when you become deeply focused. Pick up a book, solve a puzzle, or stare at your phone, and your blink rate often drops dramatically. Ironically, that's exactly why so many people experience dry, irritated eyes after spending hours looking at screens. They aren't producing fewer tears, they're simply blinking less often, so the tear film isn't being refreshed as regularly. Your brain seems willing to let your eyes become less comfortable if it helps you concentrate. But that creates an even bigger puzzle. If blinking briefly blocks vision, why would your brain ever choose to blink in the middle of paying attention? To answer that, we need to look at what actually happens during a blink. A typical blink lasts only about 100 to 150 milliseconds. That tiny movement requires astonishing coordination. Signals from the brain travel through the brainstem to muscles that rapidly pull the upper eyelid downward. Other muscles reopen the eye almost immediately. At the same time, the tear film is spread evenly across the cornea, while excess tears drain away through tiny openings near the corners of your eyelids. All of this happens in less time than it takes to clap your hands. Not all blinks are the same either. Some are voluntary. You choose to close your eyes. Others are reflex blinks, triggered instantly when something rushes towards your face, bright light suddenly flashes, or an eyelash touches your cornea. That last trigger is especially important because the cornea is one of the most sensitive tissues in the human body. It contains an extraordinary number of nerve endings, allowing it to detect even the smallest irritation. Before you're consciously aware of danger, your eyelids may already be closing. It's a built-in emergency shield. But the most mysterious type is the spontaneous blink. These happen automatically, even when nothing seems to trigger them. For decades, scientists assumed spontaneous blinks simply occurred whenever the eyes became dry enough to need another layer of tears. Modern neuroscience suggests the story is more complicated. Researchers studying brain activity have discovered that spontaneous blinks often happen at surprisingly predictable moments. Instead of appearing randomly, they tend to occur during natural pauses in attention. For example, while listening to someone speak, people often blink at the end of a sentence rather than in the middle of an important word. During a movie, viewers frequently blink between scenes instead of crucial action. Even while reading, blinks often happen at the end of a phrase or paragraph. It's almost as if your brain waits for safe moments to briefly interrupt incoming visual information. Even more surprising, brain imaging studies suggest that during these tiny pauses, activity shifts between networks involved in focused attention and another group of regions often associated with internal thought and mental resetting. Scientists are still investigating exactly why this happens. The evidence shows a connection, but the precise purpose remains uncertain. One leading idea is that spontaneous blinking may help the brain reset attention before returning to the outside world. Another possibility is that the brief interruption actually improves how visual information is processed. These ideas are still being explored, but they point towards an extraordinary possibility. Blinking may not simply interrupt vision, it may help organize it. That also explains another everyday mystery. If your eyelids completely block light, why don't you experience darkness every few seconds? The answer isn't in your eyes, it's in your brain. Your brain quietly suppresses awareness of the visual interruption during a blink. Rather than presenting each blink as a tiny blackout, it stitches your experience into one continuous stream. The result is seamless perception. Your conscious mind never notices the missing frames. It's a bit like watching a movie. Between each image, there are tiny gaps, yet your brain blends everything into smooth motion. Blinking works in a surprisingly similar way. Without realizing it, your brain edits reality thousands of times each day. Scientists have also learned that blink rate changes under different conditions. It can vary with emotions, fatigue, conversation, concentration, and certain neurological disorders. Dopamine-related brain systems appear to influence blink rate as well, although scientists are careful not to treat blinking as a simple measure of dopamine levels. The relationship is much more complex and depends on many factors. Because of this, researchers study blinking in fields ranging from neuroscience to medicine. Changes in blink patterns can sometimes provide useful clues about how the brain and nervous system are functioning. Engineers are even exploring if future computers might adapt to our attention by recognizing natural blink patterns. A movement that once seemed trivial may reveal far more about the mind than anyone expected. So the next time your eyes feel tired after staring at a screen, notice how rarely you've been blinking. And the next time someone suddenly tosses a ball towards you, pay attention to how your eyelids react before you've had time to think. Both moments reveal the same hidden system at work. What looks like the simplest movement your body makes is actually a perfectly timed partnership between muscles, nerves, tear glands, and the brain itself. Thousands of times each day, without asking for your attention, each blink cleans your eyes, protects delicate tissues, keeps your vision sharp, and may even help your brain manage the constant flow of information pouring in from the world around you. Blinking isn't a pause in seeing.
It's one of the reasons you can keep seeing clearly.